Hello everybody to all over the world. Welcome in our crane-specific training. My name is Gerald Haas. I'm working for Siemens in the headquarters for crane automation in Erlangen. My chapter covers basically old stuff. Everybody nowadays is talking about Industry 4.0. But I will introduce you still the old Industry 3.0. What does it mean? Digitalization today, everybody knows, is a synonym for Industry 4.0. Go back to the history of the mankind. The mankind starts with Industry 1.0, and this was mechanization. If you think about the old farmers, they started with some oxes and cows or horses and worked with mechanical systems. My colleague Luis Cabrita introduced you some mechanical systems which are really also relevant for cranes. So a crane actually is an old stuff machine with old technology, but it has not changed so much. That's why in our crane basic course we start from the mechanical systems and go to the motor technology and to the inverter technology. Industry 2.0 was the steam engine, invented by James Watt. Industry 3.0 was, we call it electrification. Electrification means electrical motors, some switch gears, so all the industrialization which come in a huge wave over the mankind. And Werner von Siemens invented or detected the dynamo electrical principle. And it's funny to see that after 140 years, the physical principle has not changed. And now in my chapter, I'm going to present the relevance of electrical motors for cranes. So in the next 40 minutes, so I will give you some ideas what to consider for electrical motors when it comes to the application in cranes. Our experience shows that most of the wrong dimensioning or wrong selection of motors is an issue, and most of the field observations when it comes to malfunction is because of somebody did not really understand how to select size and find the right type of electrical motors. So we will start now. We will cover different topics in this chapter about the relevance of asynchronous motors in crane application. Martin Metz, my colleague, previously introduced you the physics of the asynchronous motor, and I will be more guide you into practical application, how to select these motors and to prevent mistakes by using or selecting these motors. Let's start with the first issue. There are different motor mounting methods for the cranes, of course. It depends on the mechanical system, what the crane OEM is used for the different drive gears. So here on this slide, I have indicated the most relevant types of mounting for cranes. On the left side, you see so-called foot-mounted types without flange, and on the right side, you see mounting types with flange. The most important thing is when you select the motor in the catalog and you define the type of mounting, that afterwards you really mount this motor in a way as you select it. Why is this so important? Here you see in green that we have a location of the so-called drain hole. A crane is a machine who is installed everywhere in the world, everywhere. indoors, outdoors, at sea harbors, for example, with salty environments, in bulk terminals where we have dusty environment. And so we have lots of cranes who are standing outside. And what does it mean when a motor is installed outside? The motor experienced different temperatures between daytime and nighttime. That means the pressure outside and inside the motor, it depends on the temperature, will change. And that leads to every motor that there will be condensing water after a certain time in the motor. And this you cannot prevent, doesn't matter what degree of protection the motor has. Even through the ceilings, the moisture or the humidity of the air goes in and goes out, and that leads finally to the fact that some water will remain in the motor. You cannot prevent this, but you have to take care that the water can go out again. And the most common possibility for that is to have a drain hole. A drain hole at the lowest point of the motor. That means the water will go in through this effect like a sucking pump with different pressures outside and inside. And the most important thing is that you get rid of the water inside. For example, if you order a motor for mounting type IMV5 and afterwards you make some changes and you mount this motor like IMB3, then you would have the drain hole, which is indicated by this green arrow, not on the deepest point where it should be in order that the water can go out, but it would be in opposite on the top of the motor. That's a very important thing in the cranes world when it comes to outdoor installations. The drain hole. It's a classical issue for our service guys for many, many years. And I later on will show you the effect, what happens when the drain hole is on the wrong position or when the drain hole plug is not removed when the crane has become on site. A second thing is the bearings. It depends on what type of mounting you select. There can be different bearings. There can be cylinder bearings or ball point bearings. And you can imagine, for example, in this IMV5, you have the load of the rotor at the bottom of the motor, and in IMB3 it's quite different. So sometimes we see that people order motors for a certain installation and then they change the construction, and this leads to malfunction. The next issue for crane relevance are the different cooling types according to EN. There are, let's say, 5 cooling types which are most relevant for cranes. Let's start with the IC01, self-internal cooling with shaft-fitted fan. As you can see in this drawing, the air will be sucked in on the B end of the motor and blown out of the A side of the motor. And since it's internal cooling, it indicates that the air goes really through the rotor and the stator. But it does not automatically indicate the degree of protection. This we will cover later on. Then IC06, forced internal cooling with blower fan, but in that case it's an external blower fan and not a shaft-fitted fan. Then we have also applications where we just used self-service cooled motor types without any fan. This is very relevant for some crane types, for the gantry motors, because we have lots of cranes who are working like a ship-to-shore crane, is unloading and loading a ship and stands for a long time at the same position. And after a certain time, when this job is finished, he just traveled to the next row of the container compartment, and that means the crane is traveling for a very short time and then comes to a standstill. That means for the motor that the thermal utilization is not very tough, and that's why whenever it's possible we use these gantry or trolley motors without any fan. I will explain later on what is the benefit and what is the disadvantage if you install a fan in gantry drives. Then we have some application IC411, self-service cooled with shaft-fitted fan. The difference to the first one is that we have a surface cooled. IC01 was internal cooled, not surface cooled. And here IC411 is self-service cooled with shaft-fitted fan. Shaft-fitted fan means, of course, the cooling is the best when the speed is very high, and the cooling effect is lower when we have a low speed, low RPMs. And finally, for cranes, there is one more relevant cooling type. It's the IC416 forced service cooled with a blower fan. In that case, it's with an external blower fan. Okay, let's have a look to some examples of motor types, some images. Here we see a self-ventilated IC411 motor, rib-cooled, so that means self-ventilated, shaft-fitted fan. The fan is installed after the cowl here on the B side of the motor, and the shaft-fitted fan blows the air through the surface, through the cooling ribs. A different type could be here forced ventilated IC06, and in that case this is a very new design. Here the cooling air is blown through the ducts of the stator, and in that case this motor has a degree of protection of IP55. I will explain soon what does this IP class mean. And here you see the housing of the motor, you see the external fan, and in that case the air is not blown via the surface, it's in the stator sheets package. And here we have a motor, what I mentioned before, a non-ventilated self-cooled motor. So this is a motor without any fan, and the advantage, if you don't have a fan, then you have a completely closed design. And if you have a look to the environment of this motor, you see that this is a very dusty and dirty environment. And in that case, it's in a salt loading harbor where you have all kind of salt and other particles. Yeah, so now we come to a very important thing for crane applications. It's ingress protection. Most of you have heard IP class IP55, IP23, IP65. What does it mean? According to IEC standards, this classification means that the first digit, for example IP5, the first digit is for solid particles. That means protection against ingress of some dust, sand, or even mechanical tools. And the second digit shows the resistance against liquids. So when we have a motor for cranes installed outside in the ambient, we need, of course, a higher degree of protection than inside. For example, standard for outside installations at Siemens is IP55, and this is sufficient for most of our application. Siemens, as an industrial company, of course, offers a huge variety of different motor types. Here we see, let's say, an overview of the different motor types. On the left side, we see motor types who are able to run directly on the grid and also on converter operation. This we call DOL, direct online, or VSD, variable speed drive. On the right side, we have a motor range who can run only with converter. We see later on the relevance, what does it mean. And here you see the highlighted motors are the most relevant for crane applications. We have different types, and what I wanted to show you, what we indicated here, is for example where we have DOL motors or VSD motors. Our goal is not in this training course that you learn the different Siemens types and the Siemens special naming. No, for us it's just an overview, and we want you to understand mainly the different mounting types, the different degree of protection, and the different cooling types. Here you see some details about these 4 highlighted motor families, and when you have a look to the table sheet, for example, here are the different types, but it's not necessary for you, it's not necessary for the exam on Friday that you learn different Siemens order numbers. No, for us it's more important that you understand what motors are dedicatedly variable speed drives and what motors can be operated directly online as well as the inverter. And here you see the different types of degree of protection. And when it comes to some motors, you see that some motors can be offered in IP23. It's a relative open design, which mainly can be used when the motor is in a machine house and protected from any dusty ambient or rainy ambient. Then a special motor is indicated by this wording definite purpose. Definite purpose means this is a motor who is really designed especially for cranes, and here especially for gantry and trolley applications. And the main motor family, we also have some types who are dedicatedly designed for a hoist motor when it comes to high power hoist motors, mainly in harbor cranes. Here you see an overview about this squirrel cage motor. What we indicate here is that this motor is our recommendation for gantry and for trolley, because, for example, in harbor areas or rough outside areas, the gantry motor has to bear the most harsh treatment. Yeah, here you can see the technical facts, different speeds, different voltages. And the special thing is, what I mentioned, for gantry and for trolley, normally you need a holding brake or operational brake. And here we have a design where the brake is directly mounted on the B side of the motor. There's discussion in the market between about advantages, disadvantages of a mounted, directly mounted brake or a freestanding brake. Yeah, as I said, advantages, disadvantages. When it comes, for example, to a ship-to-shore crane with a rope-towed trolley, then you can imagine there are many ropes on the crane above, and it depends on the temperature. It can happen that the grease for the wire ropes can drop down to the gantry drives, and if you have freestanding brakes, for example disc brakes, then this could lead to a malfunction of the motor. So whenever we decide on the gantry type, we use this specific motor. This motor offers, let's say, all special things for this harsh environment. On this slide, you can see that there are lots of features who are relevant for rough, harsh environment in outdoor areas, covers all issues that the motor will resist for a very long lifetime. In this picture you see a broken leg of this motor. This can happen through a wrong mounting, but can also happen to some vibration. For example, when the service crew climbs up the motor, or a forklifter is banging against this motor, because there is lots of activities around these gantry motors. Here you see the different Siemens internal options, but it's not necessary for you to understand these short forms. No, it's a list where you see what all is possible. And I think we cover with this motor all needs for this application. So this is a special motor designed by the crane department. One more motor we have, that's the second motor type what we use, which is also specially designed from the crane department. This is a hoist motor for high power ratings. This hoist motor can be offered in an open design, IP23, but also in a closed design, IP55. The special thing of this motor is that it has a very low inertia. The inertia of the rotor is relevant for the torque and the power you need during acceleration. And when it comes to large cranes in a 24 hours operation, we have two issues. One is the energy consumption. The higher the moment of inertia is, the higher is the energy consumption. And the second thing is, if you have a high inertia, you need also a higher power in feeder and motor modules. The relevance of the inertia you can see here. Maybe some of you remember in school, in physics, the formula about the dynamic torque. When you accelerate cylindrical machine element, that means the J goes into the formula directly in as a multiplier. Here you see the typical torque profile when you hoist the material, then it comes to a steady state and then it goes back to zero speed. And the relevance of the rotor here in the hoist motor is an issue. On the next slide, we show you a comparison between two motor types. Let's say this motor here with a blue curve is we can say a transnormous standard motor, and this is our special hoist motor. And let's imagine we have a hoist with an installed power of 1000 kilowatt. Then you see that the inertia of the standard motor is almost double than from our crane-specific hoist motor. And as I explained before, this is relevant for power consumption, but also for the cost of the complete drivetrain, including in-feeder. Here are some details for this special hoisting motor. As I said, this motor, low inertia, we have it in IP23 and IP55 in a wide range of power with low inertia. We have for this motor again all necessary options what you need for installation outdoors or even indoors. It depends on the degree of protection what you select. And then we have things like anti-condensation heating, special paint finish, special varnish. That means special resistance against environmental impact. Pulse encoder drain hole, what I explained before, on the lowest point of the mechanical installation. Larger junction boxes and also necessary things you need for crane application. Then we have a series, cymotic severe duty, where when we have cranes, let's say industrial cranes or cranes in a powerhouse who is not operated very often, then the energy efficiency is not so relevant, and this is a cost-effective motor type for, let's say, in-house installations, also for outdoors installation, but mainly for industry cranes or for some applications in harbor cranes, for example, for a boom hoist. So in general, the motors for cranes are speed controlled. That means we have a closed loop speed control, and for that we have different types of encoders. What we can use, we have a hollow shaft encoder, which we use, and we have a flange mounted encoder. If you have selected a motor in IP55, then you have to take care that the mounting measure of the encoder should also be IP55. It makes no sense when the motor has a high degree of protection and then you would have a weak mechanical connection where water ingress or ingress of other particles can happen. So we have the open design and we have a closed design. An example, again, we have a machinery house. Here you see it's inside a protected area, then we can use the hollow shaft encoder. The issue here is that when it would be outside installed, then we would have a weak part here where the hollow shaft encoder here is connected to the B-side shaft of the motor, and that means this design would not completely closed, and this would be a very bad design for outdoor installation. Indoor installation is a good solution with a hollow shaft encoder. Here, a typical example for the flange mounted encoder. As you can see, for this design, the motor is totally enclosed. There is no access to any shaft. There is not any open design where some environmental parts can come inside. Many people think if I take care and the motor is IP55, then I'm fine with, but for outdoor installations, you have to have a completely closed design. I show you later some examples which this was not considered, and this leads to lots of trouble and malfunction. Here we have an overview. We distinguish between industry applications, like indoor applications, or we call it indoor heavy. So indoor light application could be some cranes in a manufacturing area, in an assembly area. And indoor heavy is rather more than in metal industry, where we have heavy, hot, dusty environment. Then we have to consider different motor types. And we also have industry cranes for outdoor applications. This could be in a wharf, for example, a shipyard crane, a Goliath crane, or this can also be a storage handling outdoor crane, all possible. And for harbor, we also distinguish between machine house and outdoor. And this issue here, we can see that it's so important, and we can see so very often bad installations, which leads then to a non-satisfied operation. In the following, we have prepared some selection sheet for some harbor cranes like ship-to-shore crane or the rubber-tired gantry crane, where we indicate what is the best selection for what kind of gear. So for hoist, gantry, trolley, boom, or in the rubber-tired gantry crane, hoist, gantry, trolley. And the orange highlighted types of motors are still manufactured in China. These motors are well established in Asia, And that's why it makes sense to manufacture these motors still, but mainly for sales in Far East. There will be some questions in the exam when we ask you what type of motor would you recommend, for example, for a ship-to-shore crane, for boom hoist, or for gantry, or for trolley. So these two slides actually are quite relevant for the exam. In the following, we cover some issues about motors, which is also important for crane application, where we can see that sometimes there are really bad selections because of misunderstanding. On this sheet, we listed the most relevant standards for, let's say, for electrical motors with relevance for crane application. Bearings and greasing. One big issue what we can see in the field of cranes, that the lubrication of motors is not properly done. That's why you should have in mind the re-lubrication interval and the re-greasings of different motor types. You can see the different. For the smaller frame size, it can last up to 40,000 hours, and you see the bigger frame size, for example, 280 up to 450, is definitely shorter, much shorter than for the smaller frame size. Yeah, then we have some specialties. As I explained, cranes are installed everywhere, all over the world, from the Sahara up to the Arctic, and that means here we face with different tough environments. Here is just a reminder what to consider for cold temperatures. That means the bearing lubrication is somehow a special type. Sealing rings has to be considered, and the shaft material for very cold temperatures up to minus 60 degrees has to be considered. It's just a reminder for details. You just should remind when it comes to very extreme temperatures, there's something to be considered. For example, for hot temperatures, we need special paint finish. Also, the bearing lubrication and the grease retention is different than for standard environment applications. Yeah. That's just a short overview that you always consider when you select a motor. How is the ambient temperature? But very often it's already in the specification indicated. That's a picture I like because nobody understands it. You see a motor with a greasing nipple, and there is a plate, do not grease. What does it mean? It makes no sense, right? Some maintenance and service people in the factories, they love to go with the grease gun and greasing everything what they can see. And as I explained before, you have to consider certain intervals for greasing. If you do greasing too much, then you damage the motor, because then the grease can go not only in the bearing, but it goes out of the bearing and goes in the stator of the motor. And the isolation of the copper wires and greasing material leads to a malfunction of the isolation. So that's why this picture does not allow the crew to grease too much. Here some other types issues about motors is temperature class. In the past, actually, there was also a class B. This is not any valid anymore. So standard at Siemens is class F, and on special little bit higher price special request, it's a class H. Here you see the temperatures. The motor, actually, all motors are designed for standard, or they are stamped with the power ratings for ambient temperature of 40 degrees. And here you see the different time rise limit and the final limit what the motor has. And the yellow compartment at the top here is actually here at this temperature 165 the motor protection should react, and this yellow part is safety margin actually. Temperature class, it means we have temperature class, and to protect the motor we have measures, we need measures to protect the motor when the motor is overloaded so that it becomes not too high temperatures in the winding. A simple measure are bimetal switches. This is a measure when you have very simple grains, then we can use these bimetal switches. That's the most simple measure. Another measure is with PTC thermistors. That means there is a certain characteristic in the sensor, and when it comes to too much high temperature, then the resistance is changing in a way that the dripping device will open and give a signal for example, for warning or for shutdown. For very expensive motors, there is also a possibility to monitor it via analog signal, not only dripping and warning. So we can continuously monitoring the temperature, for example, and can display it or store it in the crane management systems. This allows to show the characteristic over the lifetime, and when the temperature gets over the time hotter and hotter, that means there could be an issue with, for example, friction in the bearing or damaged gearbox. Within the dynamics family we have different possibilities. Here you see the possibilities for single-axis application, for multi-axis application, and here you see the different types, what I mentioned before. It depends on the manufacturer of the motor or on the selection for the customer. There are different possibilities to protect the motors and to monitor the temperatures. Here you just see an example of a stator. Here you see the insulator in stator slot, some protection for the windings in the end slot, and here you see the insulator tube for the thermistor. That means the sensor normally is installed within the stator where the hottest area is expected. Some issues about voltage stress. According to IEC, there was a trial to distinguish between different categories. We have 4 categories, A, B, C, D, where the impulse rise time and the overshoot factor is defined. But all the manufacturers for motors, they have their own system and they have their own secret when it comes to the voltage resistance. At Siemens, we have our isolation system that's called dytu. And here you see 2 different kinds of isolation. Class A, standard isolation. Class B, non-standard isolation for higher resistance of pulses. And this chart here shows you different rise times and different stress levels, which mainly comes from the IGBT switch of the converter, and the state-of-the-art IGBTs, they switch very fast and very tough accurate. Now we come almost to the end with some practical photos which shows what is a good installation, what is not so nice. For example, this is a weak design on the left side. I try to explain it because even if the motor has IP55, but you see that the impeller here is installed, and at the end there is a hollow shaft encoder, and that means when this installation would be outdoors, this is a weak point here where salt water or rainwater will go through and over the time goes into the motor. For outdoor installations, this is rather the optimum design where I said the brake is flange mounted and the encoder is flange mounted. Some weak design, you see vertical installed gantry drives. There is a fan on the other side here at the top. And as I said, for gantry drives, we should use a very close design. And there are some other issues. For example, this small cable here goes in the terminal box. Never use cable entry from top, because for outside installations, when it's raining, the rainwater follows the cable, and that means the water always stands here at the cable gland, and it's a matter of time until the water can increase. Again, an example here as a weak design with the issue that the shaft is not completely protected by flange connection. I have to repeat myself always, outdoor installations need completely closed build-ons like brakes and encoders. That's a similar thing I just wanted to show you. If you don't follow it for outside installations, it's a matter of time, and wrong designs sometimes leads to trouble and additional costs. What you also should not do is select motors for outside installation, for example, with aluminum junction box. As I mentioned before, if you have chemical environment or salty environment, the terminal box will be gone through corrosion after a short time. One more example here for a bad design. You see a motor. It's a foot-mounted type. And here you see the drain plug. There are two issues. The first thing is that the drain plug is not removed. And when it's an installation in IMB3, then the drain plug would be not at the lowest point that the water can go out. It would be in the middle of the altitude of the motor level. That means even if the drain plug would be removed, the motor after a time would be half full with condensing water. This is a typical picture I like. When you go with open eyes through a harbor area and you have a look to the gantry motors and you see this picture, that means where you can see that through the ceiling there is rusty water. That means the motor is filled with rusty water. And the issue is, of course, here that the motor will die early. And here I assume that the drain plug was also not removed. This picture here, this photo is not a joke. Here you see really the water after removing the drain plug. It comes out, and that means it's a lot of water where we assume that the motor was completely full. Now we come to some nice designs. This is our crane-specific gantry motor, and here you see an open cut, and here you see the special varnish and the special coating of the rotor and the varnish of the stator. And even if condensed water would go in, it would not have any damage. Nice design for a junction box. It's a great arrangement. You find here the most important one for outside is of course cast iron. I have shown you previously the aluminium type. Aluminium is not suitable. Proper cable box installation you can see here, where the power cables, for example, here arrived at the terminal box, and they are connected and screened and connected via, let's say, cable gland. And the cable gland is connected with the terminal box. And here you can view from inside, where you can see the screen of the power cables, really good connected and good fitted with the terminal box. That means on both ends of the power cable. Optimum design. Here the gantry motors you see again in a flange type design where also the encoder, and in that case we don't have a holding brake, but where no water can access anywhere. Image optimum design you see here in a vertically mounted motor on the lowest point. Here is a drain plug. It's the right position here, but it has to be removed for operation. Normally through shipping the drain plug is in because we have lots of ship transport, and when the motor will be, let's say, exposed to some water in a storm, whatever, then we let the plug in, but when it comes to operation we remove the plug. And finally, again, comparison between indoor installation and outdoor installation is a kind of checklist. When you select motors, ask yourself always for what application is it and for what environment. And this is a checklist somehow between indoor and outdoor installation. So this was my section, my presentation about the relevance of motors in cranes. You could see that it depends really on the environment where the crane is installed, how to consider the different features in the right way for the selected motors. I thank you for your attention. Thanks a lot. And now you have the chance to raise questions in our Q&A session, which follows right now. Thank you.